Today we'll review stoichiometry from grams to moles, grams to grams. Hopefully everything will be okay. Okay, so in this reaction, it looks a little bit overwhelming because it looks big. But in the end, remember, in stoichiometry you need to focus only in the given and the unknown. Okay? So it doesn't really matter how big the reaction looks like. In the end, you are just going to focus on the given and the unknown. So imagine that in here, wait, imagine that in here I'm giving you sorry, oh, the helicopters, so early in the morning, nobody expected that. Okay, so let's say that I give you 200 grams of oxygen gas. Wait, okay, now it's working. So imagine that I give you 200 grams of oxygen gas and I tell you, guys, please let me know how much nitrogen gas I'm going to get from there. And this will be in grams, okay? So sometimes I'm going to write the word problem, the word question. In this case, not. I'm giving you 200 grams of oxygen and I'm asking you to find grams of nitrogen. So you're only going to focus on these two parts only, okay? Okay. So according to the plan I gave you, first we need to get molar masses, okay? In this case, molar masses are very simple to get. So this is going to be the step 0, okay? To get the molar masses. So the first one is O2, okay? So it's the same as multiplying 2 times 15,998. As I told you the other day, directly you can write grams instead, but the right way to do it, the proper way to do it is to write AMU, okay? Like this. You can write grams, okay? You can write grams. Now, this gives you 31 point something, 99.6. How much? Thank you for bringing your calculator today. Sorry, the molar mass of oxygen is 99.9. Here gives you 99.8 grams in total. Guys, you can participate in my class or you can't. The ideal is that you guys do it. If you don't want to unlock your microphone because you're so lazy to do it because it's so early in the morning, you can send a message in the chat. Okay? In that way, you can participate. Now, what is the other molar mass that we need? What is other substance that is involved in the reaction, in the known and unknown?
Nitrogen.
Nitrogen.
Nitrogen. And nitrogen is the atomic molecule, so it is N2. So 2 times the mass of nitrogen. The mass of nitrogen is 14 point something, 006. Look, I'm used to work only with the rounded numbers. I will assume that it's 006. Let me know if I'm mistaken.
It's like that.
Okay. So the final molar mass is 28.012 grams over mole each. Remember that the molar masses, you can write them as fractions. Thanks, Unisa. So this is going to be written as 31.998 grams of oxygen over 1 mole of oxygen. Same happened with this one. This will be 28.012 grams of nitrogen divided by moles of nitrogen. Okay, so there you go. You have the 2 molar masses already written as fractions. So to work with the problem, for 200 grams of oxygen, how many grams of nitrogen are going to be produced? Remember the plan. The plan is from grams given to mole given. What should I use here? Only in this part? I have to use molar mass or molar ratio?
Molar.
Molar mass.
Molar mass. Mass because of the grams, okay? And as I'm relating just the given, I will use the mass of the given. Okay, next step is from moles given to moles of the unknown substance. Here I'm just relating moles and moles. So what is going to be the conversion factor to use?
Molar ratio.
Molar ratio.
So molar ratios. And last step is from moles unknown to grams unknown. Then I have to use
Molar mass.
molar mass, but this time of the unknown substance. So let's start with the grams given. They are giving us 200 grams of oxygen. Okay? I'm going to write the formula again. Qué bonito. Okay, now I'm just going to follow the plan. So we start with the given. Grams given. I have 200 grams of oxygen gas. Okay, I begin with this. And then I use my first conversion factor. That is molar mass of the given. How do I write the molar mass of the given? This one, how do I write it? Like this or in the reciprocal form?
Reciprocal.
The reciprocal form. The grams down and above the moles of oxygen. Make sure you get cancelled grams, oxygen and oxygen. And we next continue with the other step. The next step says that from mole given to mole unknown, I have to use the mole ratio. What is going to be the mole ratio between oxygen and nitrogen? What should I write up?
2 moles of nitrogen.
2 moles nitrogen. And what should I write below?
9
9
moles of
moles.
oxygen.
9 moles of oxygen. Okay? With this, you cancel moles with moles, oxygens with oxygen. In the last step, it says that I need to convert from moles unknown to grams unknown. So I need to use the molar mass of the unknown. The molar mass of the unknown is this one. How should I write the molar mass of the unknown? Like this or the reciprocal form?
Like that.
Exactly like that. So in here, you write 1 mole of N2 below and the 28 grams above. Remember to specify remember that you have to specify the unit and the substance. Okay? So moles and moles are units, but the substance are nitrogen. So you also need to get rid of the substance. How much do you get in total? Remember that you multiply everything above. You send me your answer in the chat once you have your definite answer. Okay, 38.91. So what does this answer mean? That in order to get at least 38 grams of nitrogen, I need to use 200 grams of water. Around half a pound of water is going to produce 38.91 grams of nitrogen. This is what is produced. It wasn't water, it was oxygen. So remember, what are you always going to do whenever you have a grams to grams conversion? You're gonna get the molar masses of the substances involved. How do you know if you have to do grams to grams? Because of the information provided. I'm giving you grams of oxygen and I'm asking you to find grams of nitrogen. Okay? So, yes, you have to take a look to the units that are involved. Ouch, sorry. Okay, in the chat, write if you want to, if you have a doubt or something, write it to me in the chat so I can review that part, okay?
Miss, I just have a question.
Okay. Tell me.
Well, is that it you said that there are produced 38.91 grams of nitrogen, okay? And I was thinking that we were not, that it's not like it's required 38.91 to make other things.
Well, if you want to know how much water you can get, you can also do the analysis between the two substances, between oxygen, to know how much water is going to be produced. Or you can do it like this. You can also say, okay, I'm going to use 200 grams of water, and I want to know, for example, how many grams of CO2 or methylamine are going to be necessary. Okay, so you also remember that we are always comparing two units, I mean two substances. Sometimes we're going to relate water, some other times we're not. But for example, here, if you want to analyze the water situation, you can say, okay, with this reaction, all I need is I want to get water. Okay, I want to get water. For some reason, you are interested in water, so you say, I need to obtain 200 grams of water. So I want to know how much methylamine I have to use. What should I do next? Well, this is going to be the example number 2. So if I use 200, if I got 200 grams as a result, if I want to get 200 grams as a result, I want to know how much methylamine I need to use. So I'm going to start from getting the molar masses. Wait. Example number 2. It's going to be this one. I'm using the same reaction as you can see. Wait. Okay. Let's say that this is the reaction that now has to consider. So I need to get as a step 0 the molar masses of CH3, NH2, and H2O. So let's see. Molar mass. Molar mass step is first substance CH3 and H2. In total, what you can do is you are going to count the number of atoms of each. For example, carbon, you have 1 carbon. Hydrogen, you have 3 here and 2 over there. In total, you have 5 hydrogens. And you have 1 single nitrogen. So this is going to be the molar mass. You multiply the masses of each. I'm going to use the rounded values, guys. Okay? For carbon is 12, if I'm not mistaken. Because of the lack of time, I'm going to be using the rounded values. I'm sorry. Hydrogen is 1 gram only, and nitrogen is 14 grams only. Okay? So how much is this in total? Wait. How much is this in total?
31.
31 grams of CH3 NH2 over 1 mole of the same substance. Okay. The other molar mass of our interest is water. That one we already know, but still, I know. Sorry, guys. Is that whenever I use the the iPad, I press the 0 by mistake. Sorry. Do you hear the barking sound? That's also my neighbor. So finally, water appeared. Sorry, I have such a delay in hearing that. Okay, my connection is worse. Wait. Okay, so let's begin to solve the exercise. We start always, as I told you, we always start from the given, but we also follow the plan, okay? The same plan is going to work for us. So if you want, you can keep it handy for homework purposes or class purposes only. Okay, so here's your plan. We start from grams given to mole givens. Okay, I need to use the molar mass of the given. The given is water.
18 grams of H2O.
Mm-hmm. 1 mole H2O over 18 grams H2O. Grams, grams, water, water. Now that we have accomplished the first step, let's go to the second step, that is from mole given to mole unknown. How much is this? What numbers I have to consider according to the equation that I gave you? What's the molar ratio?
4 moles.
14.
4 moles over 10 moles. Okay? Water, CH3, NH2. Okay, so in here you get rid of moles with moles, water with water. And now next step is from moles unknown to grams unknown. It says molar mass of the unknown. What is the molar mass I have to use?
31 grams
31 grams of,
CH3 and H2.
and below
1 mole.
1 mole CH3 NH2. you get rid of the same units, and in the end, the remaining unit is now. How much did you get?
137.
137.78 grams CH3 and H2. How do you interpret this answer? In order to get 200 grams of water in the chemical reaction, you need to at least use 137 grams of methylamine, if I'm not mistaken. So you can say this like to produce 200 grams of water are necessary to use 137.78 grams CH3 and H2. So if a chemist wants to get 200 grams of water, that's the exact amount that he must use in the chemical reaction. That's what it means. Guys, remember that you have to get used to round your answers, okay? So in here you got 137.77 and so on. Remember, we used only two decimal places, and we need to take a look to the third number after the decimal point. If it's 5 or more, then you have to round, and rounding implies to add one decimal, okay? So instead of 0.77 here will become 0.78. Remember that you have to round your answers. Now let's do one exercise a little bit simpler. I'm giving you 200 grams of water, and I want to know how many moles of CO2 are going to be produced. So what type of conversion you have to do in here? Gram to gram, gram to mole.
Gram to mole.
Gram to mole, okay? So the plan for gram to mole is this one, okay? With one less step. This is your plan. So you're going to be relating just these two substances. Okay? So let's begin. Okay? You need the molar mass of the given. We already know the molar mass of the given because the given is water, and we already know the mass of water because we got it in the exercise before. So I'm going to skip this step of getting the molar mass of water because I already did before. So get the molar masses that you need for the problem. Okay? Of your given, which is water. Now, given the molar mass, now let's begin to solve the problem. We start with the given, 200 grams of water. It says that to get the number of moles, I need to use the molar mass. How should I write the molar mass? Where should I write the grams?
Down.
Down. 18 grams of water down over above 1 mole of water. Grams and grams, water and water is gone. And now it says that from moles given to moles unknown, I need to use the molar ratios. What are going to be the molar ratios in here? What should I write up?
4 mole of CO2.
4 mole CO2 up, and below them the 10 mole of water. Moles and moles, water and water. And this gives you
4.44.
4.44. Should I round this answer? Should I round this answer?
You can put a line above.
So because 4 is less than 5, you just ignore the last decimal and then moles of CO2. If I do this, I need to get rid of the last